So actually what I would like you to do is just look at what you did for your first step. Look at what you did for your first step when solving that equation. There are 4 possible different first steps. Compare with your table and see what steps you use. You may not have done the same thing. There are 4 possible correct first steps. So compare with your table what you did for the first step. Just the first step. All right, raise your hand if you added 3 to both sides first. That was your first step, adding 3 to both sides, okay? Raise your hand if you added 9 to both sides first, okay? Raise your hand if you added 7x to both sides first. Yep. Anyone subtract 5x? So it's probably the least common one, but did anyone subtract 5x? Yeah, you could also subtract 5x from both sides. All 4 of those possible first steps, all valid, okay? So it doesn't matter which one of those you did. You'll get the right answer if you continue doing the correct steps, okay? I think I saw the most hands for adding 9 to both sides. So I'll do that one. But this doesn't mean you have to do this one. If you add 9 to both sides, at some point we all should move the x's over to one side. So here, if I added 9, I'm going to subtract 5x. And I'll end up with 6 is equal to negative 12x. Everyone should get to this step, or your negative might be with your 6 instead. So you might have a negative 6 and a positive 12. That's fine. But everyone should have 6 and 12x, one of them negative. Then divide by negative 12. And you should get x equals negative 1/2 or negative 0.5. So that should be your final answer, negative 1/2 or negative 0.5. Okay, so everything today, you're going to solve the things just like you solved this equation, okay? This equation has one answer. X is equal to negative 0.5. If you plug that into the original equation, it will make it true. It will be equal if you plug it in, okay? Today we're going to solve inequalities. Inequalities are expressions with these symbols instead of an equal sign. That's literally the only difference, is that you have these instead of an equal sign. You solve them the exact same way. No difference. Just like you're solving an equal sign. If you need to, put an equal sign in there, and then at the end, put that symbol back in, okay? It's the exact same if it's an inequality, okay? The only small difference that sometimes might happen is if you multiply or divide both sides by a negative. Anyone remember what you would have to do if you multiply or divide both sides by a negative? Yeah, you gotta flip the sign. Like if it's going this way, you'll flip it backwards, okay? So that's the only thing that's different about inequalities. So let's look at a very simple example here. This is an inequality. If this was an equal sign, what would you do first to get x by itself? Multiply by negative 4, right? So it doesn't change that fact that that's an inequality. You're still going to multiply both sides by negative 4. So you'll get x and negative 20. So you get negative 20 on this side, x on this side, but I multiplied by what? What did I multiply both sides by? Negative 4. So what am I have to do to this symbol? Just switch it, flip it. So this is the solution to this inequality. When you have a solution to an inequality, there are infinitely many answers, okay? The first problem we did when we found the equation, there was one answer. X was equal to negative 0.5. Now, x is anything less than negative 20. Give me an example of a number less than negative 20. Any number. Negative 21. That is a solution to this inequality. If you plug it in, it will make the inequality true. Give me another number less than negative 21 or negative 20. Negative 30, negative 45. Those are both solutions to this inequality. It could even be negative 1,000, right? Negative 1 billion is going to be a solution to this inequality. So are there infinitely many answers here, right? And that's what this is describing. This is describing the set of all numbers that are solutions to this inequality, right? So all of those numbers are solutions. Now for this one here, if I want to get x by itself, what would I do first? Or what would I do to both sides? Yep, divide by negative 5. Get rid of that negative 5. So you'll have x and negative 4. What did we divide by, Garrett? Negative 5. So because I divided by a negative, I'm going to switch the sign. So this is the solution to this inequality. The solutions to this inequality are any values x that are greater than negative 4. So give me an example of a solution to this inequality. 1 is greater than negative 4. What else? 5. What about negative 4? It says only greater, right? It have an equal to then negative 4 would be okay, right? But since it's just greater, negative 4 will not be a solution. Okay, so now let's solve a more complex one. You're going to try it on your own first. So take this inequality and solve it. Remember, nothing changes. It's just like if it was an equal sign. So go ahead and solve that inequality for x. We'll do the graphing together. Just solve that inequality for x. And if it's confusing, turn the inequality into an equal sign and then just change it back at the end. Matt, what did you do first on that one? Number 1. Added 3? Raise your hand if you also added 3 first. Anyone else add 3? Valid first step. Anyone do something different than add 3? You also could add 9 first, right, to both sides. That's be fine. Add 7x or subtract 5x. Do you notice anything familiar about this problem? Is it almost the exact same as the review problem that we did at the beginning? What's the only difference? Equals inequality, right? That's the only difference. So you could have solved this one the exact same way you did the other one. Maybe you chose to do it a different way. That's fine. Let's see. Add 3 first was what we said this time was the most common answer. So I'll do that this time. I probably would add 7x to both sides as my next step. Divide by 12. And you get x is less than or equal to negative 1/2 or negative 0.5. So now our solution is any number x that is less than or equal to negative 0.5 or negative 1/2. If you divided by negative 12 at in yours, that's a common thing to have to do. Just make sure you flipped your sign if you divided by negative 12, if you had negative 12x, so that it's the correct direction. So this is the solution to this inequality, but we need 2 more parts for most of our answers when we're solving inequalities. We're going to graph the solution and then write it in interval notation, okay? So this solution says any number x that is less than or equal to negative 1/2. Give me an example of a number less than or equal to negative 1/2 or negative 0.5. Any number at all. Okay, what's a number less than negative 1/2? Pick a number then. Pick any number. Go bigger. Just do a nice number. 1. Negative 1 or positive 1? Is positive 1 a solution to this inequality? Is that less than negative 1/2? No. So what about, is negative 1 less than negative 1/2? Yeah. So negative 1 is a solution to this inequality. Positive 1 is not, right? What about negative 5? Is that a solution to this inequality? Is that less than negative 0.5? Yeah. What about 2? Is that a solution to this inequality? Nope, because that's not less than negative 1/2. What's up? With my work, no, because I only divided by positive 12. If you divided by negative, there's a situation where depending on what you did, you had a negative 12x, and then yes, you should. But it should look like this still. Okay, so now we need to draw all of these possible answers on the number line, right? So we're talking about every number less than or equal to negative 1/2. So we need to put a closed circle at negative 1/2, so it's between negative 1 and 0. And remember, it's closed because it's equal to, right? Negative 1/2 is a solution, right? It's less than or equal to. And then because it's less than, which way does my arrow need to go? To the left, right? So it's all the numbers less than negative 1/2. So negative 1, negative 2, negative 3, negative 4, negative 1.5, right? Negative 2.5, negative a bajillion, right? All of those values are solutions to this inequality. And then we're also going to write the interval notation, right? So this would be from negative infinity to negative 0.5 or negative 1/2 with a bracket because it's a closed circle. Any questions about number 1? This is what the usual type of answer will look like for an inequality. You'll get x is greater than, less than some number. You'll draw on the number line and then give the interval notation. We're going to do 2 more examples where the answers look a little bit more weird than number 1. Okay, so I want you to try to solve number 2 on your own. We'll do the graphing together. The answers will look a little weird on this one, so if you get a weird answer, don't be afraid. It's probably a good thing. So go ahead and solve number 2 for x. Okay, for this one, it really matters what you did first. So I need everyone to vote. So one option of what you could have done first is adding 9 to both sides. Raise your hand if you added 9 to both sides. Okay, raise your hand if you added 3 to both sides to start. Anyone subtract 5x from both sides to start? Okay, so we got a little bit of both. So I think 3 was the most common one, so I'll work through that one. Add 3 to both sides. And you'll get 5x is less than or equal to negative 6 plus 5x. Everyone should have gotten to the point where they did subtract 5x at some point from both sides. And this is where that gets weird, because that would be my next step here. What happens when I subtract 5x from this side? What do I get? 0. Not x, because that would be 6 minus 5 would give me 1x, right? I get 0. What do I get on this side when I subtract 5x? 0 for this part, plus negative 6 is just going to leave me with negative 6. So if you added 3 first, this is what it should look like. 0 less than or equal to negative 6. If you added 9 first, yours should be 6 less than or equal to 0. You added 9 first. If you subtracted 5 first, you should have negative 3 less than or equal to negative 9. That's what you could have gotten. So all of those would be inequalities that you might see. Negative 3 less than or equal to negative 9, 0 less than or equal to negative 6, or 6 less than or equal to 0. So all of those are possible ways that your answer can look right now. Everyone have one of those? Okay. Can I graph this? How do I graph 0 is less than or equal to negative 6? Is there an x here anymore? No, this one had an x. That's why you were able to graph this one, because this says x is less than or equal to negative 1/2. X is all the answers, right? This doesn't say anything about x at all. The x's have disappeared, so this is not a solution anymore. If there's no x, it's not a solution. It's just a statement. 0 is less than or equal to negative 6. That's a statement, right? All of us should just have a statement. So I want you to look at the statement on your paper and decide, is it true or false? And write that down next to it. So look at the statement on your paper. There's no x's anymore, so it's just a statement. And decide, is that true or false? And write down true or false next to it. For those of you that had 0 less than or equal to negative 6, is 0 less than negative 6? Absolutely not, right? It's bigger than negative 6, so this is false. All of ours should be false. 6 is not less than 0, and negative 3 is not less than negative 9. So all of these are false statements. So what does that mean? If all your x's disappear and you have a statement left, you have to ask yourself, is it true or false? If it is false, that means it doesn't matter what x is, this is never going to be true. So there is no solution, okay? If you get the statement is false, it is no solution. There is not a single value of x that will make this true. So these are the most common ways you'll see your answers. Like this, you'll have an x in it when you can graph it, but if your x's disappear, you're just going to ask yourself, is it true or false? And then if it's false, it'll be no solution. So there's nothing to graph because there's no answer. Any questions on number 2? All right, solve number 3. Solve for x. Depending on what you do first here, your answer might look a little different. You could have added 9 to both sides first, you could have added 4 to both sides first, or you could have subtracted 7x. Those are all valid conclusions. I'm going to add 9 first. Everyone should have tried to subtract 7x from both sides at some point, and the x's are going to disappear. So there should be no x in your final inequality, okay? If you added 9 first, you should have 5 is greater than or equal to 0. If you added 4 first, you should have 0 is greater than or equal to negative 5. And if you subtracted 7 first, you should end up with negative 4 is greater than or equal to negative 9, okay? So ask yourself if that's true or false, and write down true or false next to your statement. Now that the X has disappeared, we just need to know, is this is now a statement, it's not an answer, it's just a statement. So we need to know, is it true or false? Write it down next to yours. Is mine true? Is 5 greater than or equal to 0? Yeah, 5 is greater than 0, so that's true. All of ours should be true. -4 is greater than -9, and 0 is greater than -5. So all of those should be true. Well, what does that mean if it's true? Well, that means that's going to be true no matter what X is, right? X can be any number in the world, and this will be true. So that means it's all real numbers, right? Every single X is a solution. All real numbers. So it would be the entire number line. So you can do big old arrows in both directions. So if you get an X in your answer, right, you're just graphing it and writing an interval. That's what most problems look like. Every now and then, X's will disappear. If the statement is false, it's no solution. If the X's disappear and the statement is true, it's all real numbers. So those are the 3 different types of answers you'll run into. How do we write all real numbers in interval notation? Yeah, negative infinity to positive infinity. So for these problems, you should have a solution, a graph, and an interval. Unless there's no solution. Then obviously you don't have any. Any questions about 1, 2, and 3? We're going to do one more type of problem, and then we're going to practice. Okay, now for number 4, this is a compound inequality. How does number 4 look different compared to 1, 2, and 3? What's different about it? There's 2 inequality symbols now, right? So you're still going to solve for X. X is going to be in the middle usually, right? You're going to get X by itself in the middle, but when you do something to one part, you have to do it to all 3 parts now, instead of just 2 sides of the equation. So in the middle here, if I want to get X by itself, what would I do first? Yeah, get rid of which part? The 3 first, right? And do I want to subtract though? I want to add 3. So add 3 here to get rid of the 3, but then you have to do that to all 3 parts of the inequality. Now that there's 3 parts instead of just 2 sides. So you'll have 6 is less than or equal to 4x, less than or equal to 22. Then we get to divide by 4. You can use your calculator if you want to find the outside values. You'll be left with just an X in the middle. That's when you know you're done. Or you can write the fractions simplified, either one. So either do 6 divided by 4 in your calculator or simplify that fraction. Six divided by 4 is 1.5 or 3/2. 22 divided by 4 is 11/2 or 5.5. Once X is by itself, you have your solution, but your solution is also going to be a compound inequality. If you started with 2 symbols, you should end with 2 symbols. So this is the solution, and this is a set of all numbers because there's an X here, right? This is all the values X that are greater than or equal to 1.5. So cover that up. X is greater than or equal to 1.5, but X is also less than 5.5. So we need all the numbers that are greater than or equal to 1.5 and less than 5.5. So what's an example of a number that is greater than 1.5 and less than 5.5? 2, right? It's bigger than 1.5, less than 5.5. What's another number? 4, greater than 1.5, less than 5.5, right? So all of those numbers will be in that solution. So we need to draw it. At 1.5, we should have a closed circle because it's equal to. At 5.5, we should have an open circle because it's just less than, no equal to. And then we got to draw the arrows. So we got to think about both parts individually. So this part right here says x is greater than 1.5. So it'll go to the right. And then this says x is less than 5.5. So this one will go to the left. But they're pointing towards each other, right? Bigger than 1.5, less than 5.5. So when they point towards each other, they're going to come together and connect. Like number soulmates. So our answer, our solution to that inequality are all of these numbers, right? Starting at 1.5, going to 5.5, not including 5.5, including 1.5 and all the numbers in between. So 2, 3, 4, 5, we already were listing those, and all those little decimals in between. And now we just need to write in interval notation. So we'll start at 1.5, end at 5.5, bracket on 1.5 because it's a closed circle, open parentheses on 5.5 because it's an open circle. Any questions about that one? Number 4, the compound inequality. All right, try number 5 on your own then. Another compound inequality. If you don't understand any of the steps, just ask. Try number 5 on your own. All right, so for number 5, you should have subtracted 5 from all 3 parts first to get rid of the 5. Then divide by 2. You're still solving for x, right? The x is just in the middle now. So you'll have -4 is less than x is less than or equal to 1. So this is your solution, but you also need to graph it, okay? So we're going to have an open circle on -4, closed circle on 1, And then we need to look at which way the arrows go. So this part over here says x is greater than -4. This part over here says x is less than 1. So they'll be pointing towards each other and they'll come together. In interval notation, that'll be parentheses on -4, bracket on 1, and everything in between. That's what that interval notation means. All right, I now want you working on the last 2 pages to practice. So I put the answers to the multiple choice up on the board if you want to check those. So for this first problem, you're going to solve for x. So we'll start by subtracting 11 from both sides. Sorry. Technological issues. So we'll have negative 5x is less than 15. Then we'll divide by negative 5 to get x by itself. Because we divided by a negative, we have to flip the sign. So this will be x is greater than negative 3 now. So this is our solution. And now we need to graph it. So at negative 3, we will have an open circle because it's just greater than, no equal to. And then it's greater than, x is greater than negative 3, so we'll go in this direction. And then we want to write that in interval notation, so that'll be negative 3 to infinity. For problem number 2 here, we'll start by distributing. So we'll get 4x plus 4 plus 2 is greater than or equal to 3x plus 6. Combine some like terms over here on this side. And then depending on what you do from here, you may choose to do some different steps. I probably would subtract 6 first. And then subtract 3x. And you'll get x is greater than or equal to 0. So this is our solution. And we'll have to draw the graph of that. So if this is 0, then it will be a closed circle, and we'll go to the right. And then interval notation, that's 0 to positive infinity. For this problem here, I would probably subtract 3x from both sides first, and you'll get negative 11 is less than or equal to 13. If you subtract, you could also add 11 first to both sides. And then you'll have 24 over here. Then subtract 3x. And you'll get 0 is less than or equal to 24. That's another option. No matter what you do, you got rid of your x's. So you need to ask yourself if the statement is true or false. Both of these statements are true. Negative 11 is less than or equal to 13. And 0 is less than or equal to 24. No matter what you do with this problem, it should be true. So because this is true, that means that the answer is all real numbers. So every single number. Or negative infinity to infinity in interval notation. And then lastly here we have a compound inequality. So now we want to get x by itself in the middle. So we'll start by adding 1 to both sides. Well, all 3 parts. So negative 10 is less than 2x is less than or equal to negative 4. Divide by 2 to get x by itself. Negative 5 is less than x is less than or equal to negative 2. This is your solution. And now we need to graph that. So we'll have a negative 5 and a negative 2. We have an open circle at negative 5, closed at negative 2. This says x is greater than negative 5. This says x is less than negative 2. So those are going to come together and point towards each other. And then in interval notation, this is negative 5 to negative 2.